Bismillahirrahmanirrahim. In the previous video, we talked generally about the behavioral modeling, but in this video, let's microscope our understanding and focus on the initial statement. In Verilog behavioral modeling, there are two popular statements. One is called initial statement, second is called always statement. In this video, let's discuss some of the fundamental things about the initial statements. In the initial statement, regarding initial statements, we will be talking about is syntax, is semantic, and why we use it and when we use it. So, a few fundamentals as given in this slide are all the statement which comes inside the initial statement, they become initial block. And the second fundamental thing is all the initial blocks start executing at t is equal to 0. As initial statement mostly used in the the simulation, basically used in the simulation. That's why we have to talk about the simulation time. So if there is a no delay in the simulation, all the initial blocks start from t is equal to 0. If there are two initial blocks, they will be starting at time is equal to 0 and they will be executed parallelly and concurrently. So all the blocks, initial blocks, they execute independently. There's a no sequential nature as we have a sequential nature in C programming or C++ programming. Here, all the initial blocks will be executed parallelly. And if there are more than two statements inside the initial block, we have to use begin and end keyword to group them. Otherwise, the simulator will give error. Okay. This was the first few fundamental things about it. Now, why we use it? We use it basically for two purposes. And as I already discussed with you, we use it for simulation. We don't use it for hardware. In simulation, two purposes. One purpose, initialization. Second purpose, we use it for system task, for simulator task or system task. Okay, so let's understand what is initialization and what is system task using an example in the coming slides. What is the how we use it? This is one of the template of the initial block. This is initial statements, and assuming there are many procedural statements, that's why we have grouped them using beginning. If there are more than one procedural statements, we have to group them beginning. Okay, so let's go to the example. This is the example where we are using all kinds of variations using initial statements. So there are four initial statements here: one initial state, second, third, and fourth. In the first initial statement, there's a single procedural statement or procedural assignment. In the first initial statement, there's only one initialization. M is initialized to 0. In the second initial statement, there are two initializations. A is initialized to 1, B is initialized to 0. In the third initial statement, there are two initializations. So we can note that because there are more than one initialization, that's why we have grouped these statements using begin and end. Here also there are more than one statements, procedural assignments. That's why we have to group them using begin and end. Final initial statement is about system task. In the final statement, we are using a system task to finish the simulation. So in this example, we have we have a one case where there's a single initialization. That's why there's a no begin end. There are multiple initializations, more than one procedural assignment. That's why that begin and end. There's a begin and end is used here. And there's also one example of initial statement where we are using initial statement for the system task to finish the simulation. Okay, there's another important thing to understand here. As I said, all the initial blocks execute independently and at t is equal to 0 until unless there's a delay introduced. Okay, let's look at this initial block. In this initial block, there's no delay introduced here. So this block will start executing at t is equal to 0. But in this block, we can see that the delay of 5 time units is introduced here. That's why this initialization will start from 5. And this initialization will start from 5 delay was already introduced, and there's another delay of 25. So this initialization will start from 30. Again, this initialization, because this is another initial block, this is another initial. This is independent initial block, so this initial block will start from 10. Don't assume this if this is 5, this initialization is performed at 5 and this initialization performed at 30 and then this initialization will perform at 14. This doesn't happen in Verilog here because this is independent block and this is independent block. That's why this initialization again will start at t is equal to 10 time units. And again, because this is already a delay of 10 time units, this will be added with this 25, so it becomes 35. So this initialization will be performed at 35 minutes. And simulator will finish the simulation at 50 time minutes. In the next slides, we'll see the output. So the first initialization is t is equal to 0, second initialization at 5, third initialization at 10, fourth initialization at 30, fifth initialization at 35, and simulation finished at 50. So in this slide, we have learned few basic things about the initial statement, why we use it, how we use it, and we also went through one example of the initial statement. In the next slide, in the next lecture, we will perform this example on the Vivado and we will see the output. Thank you.